Now it's time to look at exercise 213. We're going to be dealing with sum and differences of two cubes. This formula is provided on your formula sheet, and it's a case of just looking and substituting the correct parts in. Now, if you have two things that can be cubed and they're added together, it's called a sum of two cubes. If you have two terms that are cubed and they are subtracted, it's called a difference of two cubes. So we've got two formulas, one for the plus case and one for the minus case. And when I look at both examples, I can see example 1a, I've got a plus, example 1b, I've got a minus, so I'm doing an example of each case. So the trick is to look at first term and the last term, which are separated by the plus sign, and try and figure out what you would cube to generate each part. So for this one, the first part, which is always classified as A, what do you multiply by itself 3 times to get 2x cubed? Well, I know that 2 times 2 times 2 is 8, and x times x times x is x cubed. So A is in fact 2x, because, and let's just write this bit down here, 2x times 2x times 2x, 2 times 2 times 2 is 8, x times x times x is x cubed. That gives me the 8x cubed that I want. So I'm looking at that and recognizing that the bit under the cubed sign would be a, the bit under the cubed sign would be a 2x, because 2x times 2x times 2x gives x cubed. So let's undo those bits. Now, it's a matter of focusing now and trying to figure out what the b part is. So if we're looking at the b part, I'll just get rid of those parts. Let's look at the b part. B comes from, what do you multiply by itself 3 times to get 1? It's just 1. So now I can use my formula. So if I look at the formula, it says write down A, then a plus sign, and then write down B. So I'll write down A, which is 2x, remember. Then I put a plus sign, and then I write down the b value. The next thing says, look at your value of a that you've got and square it. So my value of a is 2x. What's 2x when you square it? Well, 2x times 2x is 4x squared. Now the formula says put a minus sign. Then it says times a and b together. Well, a is 2x and b is 1. 2x times 1 is 2x. Then the formula says look at the b number and square it. Well, the b number is 1, and 1 squared is 1, and there's a plus sign in the formula there. So we write plus 1. Finished. That's factorized my sum of two cubes as far as I can take it. If I actually FOILed this out and then added the like terms, I'd end up with 8x squared plus 1. So let's look at our second example. We're focusing on, let's just highlight this, we're focusing on both of our terms that are separated by a minus sign. So it's a difference of, well, it's not two squares because there's cubes in the question, so it's a difference of two cubes. So what's my value of a? Well, I know 4 times 4 times 4 gives 64, or you do the cube root of 64 on your calculator, and so you end up with the cube root of 64a cubed is 4a, and that's because 4a times 4a times 4a gives 64a cubed. As for b, what's the cube root of 27? That's 3, so 3b times 3b times 3b gets replaced with the b. Now this is a bit of an unusual question because when you look at it, if you looked at it by itself, you'd say a equals 4a. That doesn't make sense. What you need to understand is that this a and this b are the values that we're going to use in our formula, and these values here go in place of a in the formula and b in the formula. So let's see if we can rewrite our formula now. We know it's a difference of 2 cubes. So let's have a look. We get the a number minus the b number. Well, what's a? A is going to be replaced with a 4a. Take away, what's b being replaced with? 3b. So there's my a being replaced with a 4a, b is being replaced with a 3b. Now I look at the formula and I see that the a value that I have has to be squared. Well, the a value that I've got is a 4a. 4a, when you square it, is 16a squared, because 4a times 4a is 16a squared. Formula then says put down a plus, and then you need to times the a and the b values together. Well, my a and b values are 4a and 3b. 4a times 3b, 4 times 3 is 12, so you get 12ab. Then the formula says to put down a plus sign, and the b value has to get squared. Now the b value is 3b. 3b, when you square it, gives 3b times 3b is 9b squared, and it's plus 9b squared. I run out of room there in the bracket, but hopefully you get the idea. So practice those and see how you handle those, and ask me for help if they're not making sense. You need to do quite a few of them so that they become second nature. And remember, the formula sheet now has the sum and difference of 2 cubes formulas written on it. Now let's look at exercise 2.14. And this is where we're taking out common factors, but it's all mixed up. It could be any type of question that we're taking out common factors. So the first question, I can see instantly that there's a common factor of 6, so I'm going to take out my common factor of 6. 6 goes into x squared. Sorry, 6 goes into 6x squared. Nicely. 6 goes into 24 4 times, and hopefully when you look at that, you recognize that 6 times x squared gives the 6x squared, and 6 times the minus 4 gives the minus 24 in the original question. But now I need to recognize that this bracket can still be factorized further. It hasn't been simplified because it's a difference of 2 squares, which means that I've now got 6. Each bracket will begin with x, because x times x gives x squared. 2 times 2 is 4. One bracket gets a plus, one bracket gets a minus. There is my final answer for that one. Now for part B, I'm actually going to do this question a shortcut way, and if it doesn't make sense, you need to ask me in class, and I'll explain how to do it a slightly longer way that might make more sense to you. You haven't seen this before. So what I'm going to do is look at this question and recognize that it's got 3 terms, and it looks a little bit like a quadratic, but it's not, because it's not an x squared minus an 8x take away 9. The method I'm about to use works nicely when you look at the second term, the middle term. If you see it's an x squared times x squared gives x to the power of 4. If that process works where you can take that x value and times it by itself, x squared times x squared gives x to the power of 4, my shortcut method works. And here it is. It's going to be exactly the same as a normal quadratic. What numbers times to give minus 9 that also add to give minus 8? Well, numbers that times to give minus 9 and add to give minus 8 would be negative 9 and positive 1. Which means my brackets, instead of being x at the beginning of, instead of having x at the beginning of each bracket, I'm now going to put x squared at the beginning of each bracket, because x squared, when I multiply it to x squared, for when I FOIL this out, gives me x to the power of 4. Each bracket will now be with a -9 and a +1, doesn't matter about the order. Can either of those two brackets be simplified down further? Well, the answer is yes, because when I look at it, that is a difference of two squares. This bracket here is a sum of two squares, and we can't factorize that any further using real numbers, so we have to leave that. But the first bracket, I know 3 times 3 is 9, so I get x plus 3, x minus 3, and that's x squared take 9 factorised further. X squared plus 1 doesn't simplify, so it's going to stay as x squared plus 1. And there's the answer to factorising that x to the power of 4 question. Let's go to part C. Now, a lot of people don't recognise that part C, each term has a common factor of 3. So you should always take the common factor out first, which means you'll get 3. 3 goes into itself once, so you get 1a squared. 3 goes into 18 6 times, 6a. And 3 goes into 48 16 times. So now, when I look at this question, 3 is out the front. Can I factorise this bracket? Yeah, it's just a simple quadratic trinomial to solve. What two numbers times to give -16 and add to give 6? Well, the numbers I'm going to go for, what two numbers times to give -16 and add to give 6? I'm going to go with a +8 and a -2, because they times to give -16 and they add to give 6. So there's our first example on this page done. Let's go to 1 part D. Now 1 part D is basically, because it's got 4 terms, grouping in pairs. So let's look at the first pair of numbers. When I look at the first pair, this bit here, I can see that x squared is common. So I'm going to get x squared. And when I divide x squared into x cubed, I'm left with an x. When I divide x squared into 2x squared, I'm left with a 2. Now, in the second set of brackets here, I can see that there's a minus sign that's common, and 25 goes into both numbers, so -25 is common. 25 goes into itself once, so I'll be left with an x, and the -25 goes into -50 plus 2 times. Now when I look at this question, I can see I've got, let me just highlight it, there's my first part, there's my second part, they're separated by that minus sign. So in effect, it is a two-term question where I've got a common bracket of x plus 2. So let's write down the common bracket. And the leftovers are the x squared and the -25. X squared minus 25. So now when I look at my answer, I've got x plus 2 in brackets, I've got x squared take 25 in brackets. That's not finished, because x squared take 25, that bracket there, is able to be taken further because it's a difference of two squares. So my final answer will be x plus 2, it can't be simplified, but x squared take 25 becomes x plus 5 and x minus 5, because the difference of two squares, and 5 times 5 gives 25.